In this video, we are going to understand about the relation and functions. Remember one thing before we. Now, to understand this lesson, the first thing is that you must know what is relation. Now, relation, each and every input value has an output value. So, to find the relation, everything has an input and the output values. Input values can be represented by the letter X and output values by the Y. The other name of input is domain, whereas the other name of output is range. So no matter whatever the X value is, it is associated with one Y value. Or maybe many domains or many X values or many input can have one Y value, or opposite means one X value may have 3 or 4 Y values, or 3 different X values may have only one Y value, and so on. This kind of relation is said to be relation. But if we have the input, okay, or the X value or the domain is associated with the Y value in such a way that input does not repeat, yani X value do not repeat at all, no matter the output values or the Y values or the range may or may not be repeated. They can be or may not be repeat. Okay, but the most important thing is the domain should not repeat itself. We have different ways to represent the function. The first way, let's suppose the mapping diagram. We can also represent the function by the ordered pair. We can also represent the functions by the graphs, and we can also represent the functions by table. In each and every way, you will find input and output value, and in order to determine if the relation is a function or not, you must focus on the domain. That domain should not be repeated. Let's try to understand by the example. Our success criteria is to analyze the input values represented by using the mapping diagram, ordered pairs, graph or the table, and find out if it represents the function or not. Now this is the way of representing the function is said to be the mapping diagram. So what you have to see, first of all, what do you focus? Focus on the X value. You can see that each X value has one Y value. Now, if you look at all the X values, they all are different. -6, -2, 1 and 3. They all are the domains. They all are the domain. And if I want to write the range, then you can see that the range is 4, 1, -3 and -5. But better to write from least to greatest. So -5, -3, 1 and 4 are the range. You can see that the domain are not repeated, so it is a function. Let's try to find out the number 2. Now in number 2, you will have 5 is associated with 4, 2 is associated with 1, 0 is associated with -2, -3 is associated with 1. Now all the x values, you can see that none of the x value is repeated. Okay, so none of the x value is repeated, although the y value, that is 1, is repeated. This y value has an x value of 2 and -3. But to state whether the relation is function or not, we should look at the x value only. Now in the third example, you can see that the x value 4 is associated with 2 and same 4 is associated with 5. It means that the 4 is repeated. So it is not function. And if they ask you why, because 4, which is the x value, is repeated. So this is how we explain our reasoning also. This is another way of mapping diagram, and let's see if it is a function or not a function. So in example number 1, you can see A is associated with 1, B with 2, C with 3. None of the x value is repeated, so you can say that it is a function. Now in number 2, A, B and C are associated all with the 1. So y value is repeating, but x value is not repeating. And to state whether it is a function or not, we must look at only the x value, which should not be repeated. So that's why it is also a function. Now the next one, A is associated with 1, B is associated with 2. Now you can see the another value C and the y value 3 are left behind. Yani we don't know what is happening with C and D. They are not associated, so that's why also you can say it is not a function. Last but not least, you can focus in the fourth example that this value A is repeated. One time it is associated with 1 and one time it is related with the 2. So that's why it is not a function. Why? Because A, which is the x value, is repeated. Now this is the graphical representation of the function. Now in order to understand the graphs, we perform the vertical line test. But vertical line test is used to find out if the relation is a function or not a function. So if I have a graph like this, understand, like for example, this is a graph. Now what have you seen? Wherever you want to make a vertical line, anywhere you make a vertical line, it crosses the graph only one time, or it touches the graph only one time. Any line is touching the graph only one time means that it is a function. Let's suppose another graph. This is the graph. Now if I make a vertical line, so you can see that it touches the graph 2 times. So for that reason, it is not a function. So a vertical line must touch the graph only once. Let's try and find out if the relation is a function or not. Here if I make, it touches one time. If I sketch that graph here randomly, it also touches one time. So I can say that it is a function. Now graph number B, When I make a straight, this pink line, vertical line, you can see that it touches the graph 3 times. So means it is touching more than once. So you can conclude that it is not a function. Now in the C graph, again when you make anywhere the vertical line, it touches the graph more than once. So you can say that it is also not a function. Coming to the D part, if I make here the vertical line, it touches only one time. Even if I make a vertical line here, it touches only one time. So I can say that this graph represents a function. Now this is the table. The most important thing, we have to focus on the x value. Make sure that none of the x value is repeated. So look at this: 4, -1, 0, 1, 9. All the values of the x are different. So yes, it is a function. Number 5, 2, 5, 3, -4 and 5. So you can see that this 5 is repeating. So once the domain is repeating, so the relation is not a function. Next, sixth graph, 3, -1, 1, 3, 7. So again you can see that the 3 is repeating. So once any x value repeats, it states that the relation is not a function. Now if they ask you reason, so you can say that 5, which is the x value, it is repeated. Similarly, here in the next 3, which is the x value, it is also repeated. Now pause the video and check your answers. You have to find out whether the given relation is a function or not. But before you pause, let me tell you how to understand about the coordinates. In the coordinates, in the way of ordered pairs, we write the x and then the y. This is the way we represent the ordered pairs. So you have to focus on the x value. That x value should not be repeated. So you can see 3, 4, 2, 3, 4, 5 and 2. So not repeated. So of course it is a function. Now pause the video and come back. Now in the second one, 1, 3, 2, 1. You can see that the 1 is repeated. So you will say that it is not a function. Next one, 4 is repeated. So again it is not a function. Find out 7, 6, 4, 1. Nothing is repeating. So you can say it is a function. So only we have to focus on x values. Don't waste your time in watching the game of the range. Only watch the x values. Now for the graphical representation, we have to make a straight line, vertical line, and if it touches twice, it is not a function. If the line you make and it touches only one time, so yes, it is a function. So again here if we make, it is touching more than once, so it is not a function. Now this one, you can see you can make it anywhere, but there is a broken graph, right? The graph is broken. In order to represent a function, it should be aligned and it should be continuous. So you can say it is not a function at your level. Now here we can see the mapping diagram. None of the x value repeated. So it's a function. So always the x written first, then y. Okay, so look at the x. Here x is repeating. You can see from x with the 1 and -1 and 1 and 0. So it is repeating. So it is not a function. Next, again this -5, from -5 two lines are emerging. It means it is also not a function. Here you can see everything is written as -5. -5, -4, 2, -5, -5, -5, -5 means every time they are writing -5, so it is also not function. Now look at the tables. In the tables, you can have to watch only the x value. You can see in the first table, -3 is repeating, so it is not a function. In table number 2, 5 is repeating, which means it is not a function. In table number 3, none of the x value repeats. It means it is a function. In table number 4, all the values of a x are written as 5. So it is also not a function. I hope that this idea is clear to you. Look at this quickly, ordered pairs, and check which one is the function, which one is not the function. So remember that if the x value does not repeat, it is a function. Now this is 2, this is -2. They are different, so it is a function. Here 6, -4, 5, 4, 6. So you can see that 6 is repeating and that's it. 6 is repeating, so it is not a function. Find the domain and range of the opposite graph. Now, to find the domain means x value. In a graph, all the x values are on the x values. So, what are the x values? 0, 1, 2, 3, 4 till 7. So all the values including 0, 0 to 7 are your domain. Now range are the y values on the y-axis. You can see the lowest value is 0 and the highest value is 70. So 0 to 70 are the values of the range. Find the domain and range for the opposite table. So now here 0, 1, 2, 3, 4. So you can say from 0 to 4 are your domain. Now you can also write it in this way. Make a curly bracket, write 0, comma 1, comma 2, comma 3 and comma 4. This is also the way of representing the domain or range. Now here you can see y values -5, 2, 3, 7, 8. Now we don't know that if -4 or -6 are included in this table or no. So better to write within the curly brackets all the numbers which are written in the table, but separate them by a comma sign. So this is the way of representing the range.